PRV indicates variable refrigerant volume. PRF indicates variable refrigerant flow. Okay. Now, in this system, in the yesterday's session, we discussed ductable split, right? In the yesterday's system, we discussed ductable system, right?
Yes, sir. Yes, right, sir.
So, in the ductable system, can we have a individual comfort level? That means एक एक रूम पे एक एक टेम्परेचर मेंटेन कर सकता है क्या?
No, sir, not possible, sir.
So not possible. But so you want a system in such case, then we go with VRV system. Room 1, room 2, room 3, room 4, okay. So here, how much yesterday? It is 1.5 TR, right? 2 TR. It is 2.5. Here it is 1.5 TR. Here it is 1 TR, 2 TR.
सर ये अपने मर्जी से ले रहे हैं।
हाँ, कल बोला है ना, ठीक है।
ओके
So
सर।
here, so for every room, we'll select one indoor unit. वो window, sorry, वो wall mounted भी हो सकता है. So it may be a wall mounted. It may be a hideaway. It may be a cassette type. It may be a tower type. Depends on the client. Client का हिसाब से हमें लेना पड़ेगा. So now I am taking wall mounted of 2 TR. Here I am taking cassette type of 2.5 TR. Here I am taking hideaway of 1.5 TR. Here again I am taking cassette. Tower type and wall mounted. Okay, so I saw every room will have a individual indoor unit. हर room individual indoor unit होता है. Next, outdoor unit of 10 TR का लेता है. We'll take outdoor unit of 10 TR. 10 TR outdoor unit we are going to take. Now all the indoor units are connected by using a refrigerant line. Okay, like this. So to connect this piping, refrigerant piping, so this is one fitting called as splitter. We call it as splitter. And one more fitting we call it as header. So we use different types of fittings, splitters and headers in the refrigerant line to split the line into multiple lines or to split the line into two lines. So here for every company, okay, in the VRV and VRF system, VRV means variable refrigerant volume. So this system was first introduced by a company called Daikin. कौन इंट्रोड्यूस किया? Daikin इंट्रोड्यूस किया VRV सिस्टम को, and they have their patent rights. Daikin is having their own patent rights. So remaining companies also copied this system. इस system को दूसरा company भी copy किया है, and they named it as VRF system, variable refrigerant flow. So every company like VRV, sorry, Daikin, Carrier, Toshiba, okay, Samsung, n number of companies, they have their own standards and their own softwares to design this system. Pipe sizing karna hai, so what type of fittings we need to select, what type of machines we need to select, everything will come under a software. Okay, their own softwares they have. So this is how the VRV system works, and here every room has their own individual comfort. So if you are in the room 5, if you want 24 degrees centigrade as a room temperature, you can choose 24 degrees centigrade. Suppose if you are in the room 1, if you want 18 degrees centigrade as a room temperature, you can select it as a 18 degrees centigrade. Okay, so this is the advantage with the VRV system. So hope it is clear, right?
Right, sir.
Okay, next. So package I am holding, we'll discuss package after completing of indirect refrigeration system. Okay, now indirect refrigeration system. So can anyone tell me what is indirect refrigeration system?
इनडायरेक्ट रेफ्रिजरेशन सिस्टम में सर एक होता है एयर रेफ्रिजरेशन सिस्टम, वाटर और एयर वाटर.
मेरा क्वेश्चन क्या है, इनडायरेक्ट रेफ्रिजरेशन सिस्टम क्या है बेसिकली? व्हाट इज इनडायरेक्ट रेफ्रिजरेशन सिस्टम?
सर जो इनडायरेक्ट रेफ्रिजरेशन सिस्टम है उसमें हम डायरेक्टली एयर को जो है चिल्ड नहीं करते, उससे पहले कोई प्राइमरी रेफ्रिजरेंट यूज करते हैं, जैसे वाटर हो गया हमारा.
ओके
सर मैं बता रहा हूँ सर, ये पहले प्राइमरी रेफ्रिजरेंट को ये सेकेंडरी रेफ्रिजरेंट से ये कांटेक्ट में लेते हैं, फिर सेकेंडरी रेफ्रिजरेंट से फिर एयर के कांटेक्ट में आता है, तब ये सिस्टम बनता है इनडायरेक्ट रेफ्रिजरेशन।
Okay. Here in the indirect refrigeration system, there will be two cycles. First, heat exchange takes place in between primary refrigeration system and primary refrigerant and secondary refrigerant. Later, heat exchange takes place in between secondary refrigerant and air. Here, the evaporator is a water cooled evaporator. Okay. So in the indirect refrigeration system, first we will be discussing in all air system. All air system. तो ऑल एयर सिस्टम पे हमें किसको यूज करता है? AHU. We are going to use AHU. Okay. सपोज आप लोग पावर बैकअप देना है एक स्मॉल हाउस को, एक स्मॉल हाउस को पावर बैकअप देना है. वी नीड टू गिव ए पावर बैकअप फॉर ए स्मॉल हाउस. व्हाट विल बी द जनरेटर साइज?
ये कैसे पता होगा सर जनरेटर का साइज?
फिजिकल कितना बड़ा होता है?
2 किलोवाट।
छोटा. सो
छोट
इधर भी एक कॉर्नर पे रख सकता है. वी कैन पुट इट एनी वन कॉर्नर, राइट?
जी
स्मॉल
सर।
जनरेटर. बट वो ये इफ यू वांट टू गिव ए बैकअप फॉर ए बिग मॉल, तब
उसके लिए तो डीजी चाहिए सर।
डीजी बड़ा होता है ना, इट विल बी वेरी बिग, राइट?
जी सर।
So where we'll put that generator basically for a mall?
बेसमेंट में रख सकते हैं सर।
So कभी कभी we can put in the basement. Sometimes we can put in the rooftop also, right?
राइट सर।
So how much big the diesel generator is, that much big the AHU will be. Okay.
ओके
AHUs are physically very big. Okay. So that AHUs are also placed on the rooftops or in the cellars. Sometimes architect provides a separate rooms called as AHU rooms. Okay.
ओके
Now,
सर।
so what will be present in the AHU? We'll see. I'm placing somewhere outside. Okay, so inside the AHU, AHU is also a closed cabinet which consists of filter, cooling coil, and blower. Filter, कूलिंग कॉइल एंड ब्लोअर. क्या क्या है? फिल्टर होता है, कूलिंग कॉइल होता है और ब्लोअर होता है. ठीक है. So AHUs are basically used to cool the bigger areas or bigger volumes, we can say. AHUs are used to cool the bigger areas like shopping malls, airports, okay, hospitals. So the bigger applications, the commercial applications, to cool the commercial applications, we are going to use the air handling units. Assume this is a bigger space where we need to cool. So to cool this area, I am assuming 600 CFM of air is required. Okay, 600 CFM of air is required to cool this space. Clear? Now, what it will be happening? First, AHU sucks the air from outside. So here there will be opening. From here it sucks the air from outside. Hot air. So this air will enter. This air will enter into the filter. So exactly हमको कितना, how much air is required? 600 CFM outside air is required. So what we use? We use a volume control damper. Here we are going to use volume control damper to control the outside air. To control the outside air, we are using volume control damper. Okay. Now this air will enter into the filter. In the filter, the impurities like dust particles or some unwanted particles, these impurities are getting filtered. Okay, are getting filtered near the AHU, so near the filter. Now after filter, this air moves near to the coil. Where it is moving? Near to the cooling coil. So in the cooling coil, what we are going to do? We are going to, into the cooling coil, we are going to supply chilled water. From where we are supplying, we'll discuss in the next part. Chilled water solution. Chilled water solution. We are supplying chilled water solution. The water solution may be around 5 degrees centigrade. Just assume 5 degrees. And this air temperature is around 40 degrees centigrade. Now, this air should move, should cool down. So when the air is getting cooled down, okay, when the air is getting cooled down, yesterday we missed, day before yesterday we missed one point. near the coil, when it is cooling down, Hari, కొన్ని వాటర్ ఇవా. When it is cooling down, the coil temperature is a dew point temperature. 5 degrees centigrade, it may be a dew point temperature. So the water vapor molecules which is present in this air, ये air में कुछ water vapor present होता है ना, that water vapor will convert into water. That water vapor will convert into water. That water is being collected to a drain pan, and that water droplets is going to removed from the drain line. So if you notice, in the air conditioners will be having a white color pipe where the droplets of water is coming out. देखा है ना कभी एयर कंडीशनर पे एक व्हाइट पाइप होता है, उससे पानी आता रहेगा.
यस सर, ड्रेन पाइप से आता रहता है.
हाँ, वो क्यों आता है? ड्यू टू ड्यू पॉइंट टेम्परेचर ऑफ द कॉइल. कॉइल का ड्यू पॉइंट टेम्परेचर का हिसाब से. ठीक है. सो इधर क्या हो रहा है? दो चीज हो रहा है. इफ यू नोटिस, टू थिंग्स आर हैपनिंग हियर. फर्स्ट, द टेम्परेचर इज कूलिंग डाउन. पहले क्या हो रहा है? टेम्परेचर कूल डाउन हो रहा है. ठीक है. एंड दूसरा, सेकंड क्या हो रहा है? द वाटर वेपर विच इज प्रेजेंट इन दिस कॉइल is converting into water. The water vapor which is present in this air is converting into water. That means the water vapor quantity is decreasing or not?
Yes sir, that means we are controlling the RH.
Yes, the water vapor quantity is decreasing so that the dehumidification is taking place. क्या हो रहा है? वो dehumidification हो रहा है. So cooling and dehumidification. Now this air will become cooled air, cold air, or comfort air we say. Now this air we need to take to the condition space. Space को हमें कहाँ condition करना है? That condition space को लेके जाना पड़ेगा. To take this air to the condition space, okay, to take this air to the condition space, we need to create a path. हमें क्या करना पड़ेगा? Path create करना है. So that path is called that path is called as a duct. Okay, so this air will be supplied by using a supply air duct. How ducts are made? How ducts are made?
Made by fabricator.
So ducts are made by the GI sheet. We can fold it and make into the desired shape and size.
Ducts are made with GI or aluminium, right?
Ducts are
Yes,
stainless
and
steel.
sometimes SS also. In the
Okay.
food industry, we use SS duct also.
Yes. Now, as this is made with GI or aluminium, those are good conductors of heat. Those are good conductors of heat. As those are good conductors of heat, so what is happening? When this is exposed to sun or outside, again heat transfer takes place. So to protect the air, we need to insulate the duct. insulation. So now this air comes in and comes to the conditioned space. So if I directly throw this air to the conditioned space, only some air only will get cooled down like this. Okay. So to spread the air, we need to spread the air. To spread the air, we need to use a terminal. में air terminal को use करना पड़ेगा. So when we use air terminal, so air distributes in different directions. Okay. Now, assume in the first minute, okay, in the first minute, we have supplied first minute 600 CFM cubic feet per minute, right? 1 minute में 600 CFM we have supplied. Now, second minute 600, again we are supplying 600, so that in the room it will be 1200 CFM. Third minute it will be 1800 CFM. 10 minutes में, in the 10 minutes it will be 6000 CFM. In 1 hour it will be 36,000 CFM. So after 1 hour, just assume after 1 hour, will this room be comfort? After 1 hour, will this room will be comfort? Sir, hope I am audible, right?
Right, sir.
1 घंटा के बाद वो रूम पे 36,000 CFM है, तब उधर कंफर्ट होता है, नहीं होता है? Tell me.
600 CFM का ये रूम है सर, तो ये तो आपको 1 मिनट में 600 CFM बता रहे हैं, तो कितना ये कूलिंग चाहिए, कितना एयर, ये समझ में नहीं आ रहा है।
थोड़ी देर के बाद इसमें जो ठंड लगने लगेगी सर.
ओके. सो मेरा क्वेश्चन क्या है कि 1 मिनट में हमको 600 CFM चाहिए, ठीक है
जी.
1 मिनट में 600, 1 मिनट में 600, 1 मिनट में 600, ऐसे 1 घंटा मैं 600 दे रहा हूँ
जी.
तब 1 घंटा
आप कह रहे हो सर, आप सप्लाई कर रहे हो, रिटर्न नहीं कर रहे हैं हम कुछ भी, तो वहाँ पे सर जो है टेम्परेचर लो हो जाएगा ना थोड़ी देर के बाद.
टेम्परेचर लो हो जाएगा, सो टेम्परेचर विल गेट डिक्रीज, राइट?
राइट सर.
ओके. सपोज अज्यूम आई एम सप्लाइंग 20 डिग्री सेंटीग्रेड का, ठीक है, माय एयर टेम्परेचर इज 20 डिग्री सेंटीग्रेड. आफ्टर 1 hour will the room temperature will be less than 20 degrees centigrade?
Right, sir.
आफ्टर 1 आवर, 1 घंटा के बाद रूम टेम्परेचर 20 से कम हो सकता है क्या?
नहीं सर, 20 से कम नहीं जाएगा, 20 तक अचीव कर सकता है।
20 के लगभग हो सकता है, ठीक है।
जी सर।
कूलिंग हो सकता है, कूलिंग। ओके, नेक्स्ट, एनीवन, एनी अदर आंसर्स?
सर अब आदमी रूम में आदमी ज्यादा होगा तो वहाँ हीट प्रोड्यूस होता है, हीट प्रोड्यूस होने की वजह से कूलिंग मेंटेन रहेगा, नहीं तो कूलिंग बढ़ भी सकता है सर।
इधर मैं 600 CFM, वो रूम का कितना लोड है, मैक्सिमम लोड का हिसाब से ही बोल रहा हूँ।
जी सर।
So here what is going to happen is, in this area, first the pressure increases. When you are continuously blowing the air, एक balloon ले लो, you take one balloon and blow the air continuously into the balloon. What happens at particular time?
बैलून फट जाएगा।
फट जाएगा, ब्लास्ट हो जाएगा, राइट?
जी सर।
क्यों हो रहा है? Why it is happening?
प्रेशर की वजह से, एयर प्रेशर की वजह से।
Here also pressure increases, but ये नहीं
यस।
फटेगा। तब क्या होता है, इसका प्रेशर फिर इसके ऊपर लगता है। ओके, द प्रेशर विल बी मोर हियर, so that the fresh air will not enter in. First thing. Second thing, calculations are telling that not to continuously add the air into the space. When you are adding the air into the space, we need to remove, that means we need to maintain 600 CFM there. What we need to do, we need to maintain the 600 CFM. So whenever, if you come to the next minute, the second minute, whenever, if you come to the second minute, 600 CFM second cycle पे, whenever the 600 CFM is entering in, you need to remove 600 CFM out, return air. Okay, so you supply 600 CFM and remove the 600 CFM. Now my question is, so while designing any project, what is the basic designing principle every designer should have? What is the basic designing principle? Can anyone? What is a basic designing principle we need to keep in the brain?
एरिया, रूम का एरिया कितना है ये देखना है, कितना एयर चाहिए, कितना कूलिंग चाहिए, ये सब देखना पड़ता है सर। कितना हॉट एरिया है, कितना कूलिंग चाहिए, कितना,
वो तो
ये
रखना
सब।
पड़ेगा, वो तो रखना पड़ेगा, बट बेसिक क्या होता है? बेस, बेसिक प्रिंसिपल क्या होना है? आप आपका घर कंस्ट्रक्ट कर रहे हैं, यू आर कंस्ट्रक्टिंग योर हाउस, ओके? What is the main motto you will keep in your brain? What is the basic motto, basic thing what will keep in your brain?
घर के तो बेसिक डिजाइन में सर पिलर हो गया, बीम हो गया, ये सबको डिजाइन करना पड़ता है।
आप घर कंस्ट्रक्ट करने के टाइम पे आप सोचते है कि वो पूरा पिलर कहाँ पर आना है?
जी सर।
आप ही सोचता है?
जी
ठीक है, वो तो नहीं है।
आर्किटेक्चरल डिजाइन सर,
Architectural design, okay. Before that, before going to architectural design, you will be thinking something.
sir, before that is only one thing, that what is our requirement.
Requirement. Before that, you will have something.
Before that also,
You will be looking something. Still, you are coming closer.
no sir, no idea sir. You can only tell.
Okay, budget, right?
राइट सर।
प्रोजेक्ट शुरू करना है तो हमें पहला चीज क्या पूछता है? बजट। ओके, इंडिया में सस्ता में बढ़िया चाहिए। वी नीड गुड थिंग्स एट बेटर कॉस्ट, राइट? सो we need to optimize the cost of the project. While we design a system, while we are designing a system, we need to optimize the cost of the project also. To optimize the cost of the project, we have two different types of losses basically. The cost is a loss. आपका पॉकेट से कुछ भी जा रहा है, whatever the things it is getting from your pocket, those are called as losses. We have two types of losses here. One is one time loss and second one is lifetime loss. एक है one time loss होता है, एक lifetime loss होता है. Okay, one time loss means whatever the investment you are putting on the project, whatever the investments you are putting, that is called as one time loss. And lifetime loss means the running cost of the project. Got it clear? What is one time loss and what is lifetime loss? Now, tell me one point. Lifetime loss will be more or one time loss will be more?
Lifetime loss.
Lifetime loss will be more sir.
Lifetime loss will be more, right? So coming to the one time loss, lifetime losses will be more. Why? Because there will be a maintenance cost, running cost, okay, many things adds. So we need to reduce the lifetime loss. ये project पे, ये project अभी इधर देख रहे हैं ना? In this project, to reduce the lifetime loss, what can we do?
Sir, we can use a feedback system if we will get the temperature achieved. If we will get the desired temperature, then automatic our blower will stop or chilled water flow will stop.
Okay, good. Still good. You are talking some advanced system. बेसिक सिस्टम पे, मैं बेसिक सिस्टम से बात कर रहा हूँ. By using the written air. By using the written air. So how we can reduce? See, I am supplying 20 degrees centigrade air to the room. So in the room, it may be 24 degrees centigrade comfort temperature. Now the written air temperature may be in around 28 degrees centigrade max. Okay. Now to cool 28 degrees centigrade, to cool 28 to 24, will it cost more, or 40 to 20 will it cost? 28 से 20 को टेम्परेचर लेके आने के लिए ज्यादा कास्ट लगेगा, नहीं तो 40 को 20 तक लेके आने के लिए ज्यादा लगेगा.
40 को 20 तक लेके जाने में ज्यादा लगेगा क्योंकि हमारा हीट लोड बढ़ गया उसमें.
So here 28 को 20, to bring 28 to 20, I don't want to supply 5 degrees centigrade. I can supply here 10 degrees centigrade also, right? If I supply increase 1 degree temperature also, there is decreasing in the running cost of the project. When we are increasing 1 degree centigrade of chilled water, there will be a decreasing in the running cost of the project. Now, I need to protect this air temperature also. We need to protect this air temperature also. To protect this air temperature, again we need to insulate the duct. Now, every time, in every cycle, if we are reusing this air, every time from first minute to every minute we are reusing the air. So after some time, what is going to happen? सेम एयर को सर्कुलेट कर रहा हूं मैं, तब क्या होता है? सेम एयर को मैं सर्कुलेट कर रहा हूँ. आफ्टर सम टाइम व्हाट इज गोइंग टू हैपन?
Sir, oxygen level will be decreased.
Oxygen level will get decreased. Right, very good. So हमें अचानक से immediately we can't replace the air. So what we do is gradual replacement करता है. यार हमें एक VCD लगाना.
फ्रेश एयर को ऐड करेंगे इसमें सर.
Yes, yes. इधर भी एक VCD लगाएंगे. We'll place VCD 1 here. Now what I am doing? I'll be doing 590 CFM of written air. How much? 590 CFM of written air, and we'll exhaust 10 CFM of written air. 10 CFM exhaust करो, 590 CFM वापस ले लो, and add 10 CFM of fresh air. 10 CFM of fresh air. Now, फर्स्ट मिनट में 10 CFM ऐड किया, सेकंड मिनट में 10 plus 10 second 20 CFM of fresh air added. 10 minutes में 100 CFM. 60 minutes में 600 CFM. See, 60 minutes means 1 hour, right? In 1 hour, completely the air is replaced with new air. Got it? In 1 hour, 600 CFM is replaced with 600 CFM, which is called as 1 air change per hour. एक घंटा में 600 CFM हमें एक बार रिप्लेस किया है, ठीक है, इसलिए उसको बोलता है हमें 1 air change per hour. Got it? So for residential application, we go with 1 air change per hour. For commercials, like bars, pubs, we go with 2 air changes per hour. Sorry, 3. For restaurants also 3 air changes. For airports, malls, we go with 2 air changes per hour. For industrial, depending on the industry, we go with 6 to 10 air changes per hour. Okay. So this is how the air changes we select according to the application.
Sir, can you please pardon this?
Yes.
Sir, can you please pardon again this calculation?
See, every minute we are supplying 10 CFM of fresh air and 10 CFM of exhaust air. We are exhausting 10 CFM and we are adding 10 CFM. So if you go with like that, first minute I have added 10 CFM, second minute I have added 20 CFM. That means 10 plus 10. Second minute also 10 add कर रहा हूँ, but fresh air will become 20. 10 minutes में 100 CFM, and in 60 minutes it will be 600 CFM, right? Now here 600 CFM is replaced with 600 CFM in 1 hour, right?
Right, sir.
So how many times it is replaced? Only one time. 600 CFM is replaced with 600 CFM only one time. So which is called as 1 air change per hour. Suppose if I need 2 air changes per hour, that means how much air I need to exhaust here?
20.
20
How
CFM.
much air we need to take here? Fresh air?
20.
20. So then it will 2 air changes per hour will be happened here. Got it?
सर यहाँ पर 600 CFM लिया है, अगर यहाँ पर 800 CFM रहता तो
800 CFM रहता तो 800 का हिसाब से करना पड़ेगा. 800 डिवाइड बाय 60 कितना आता है?
60.
हाँ, 800 डिवाइड बाय 60 करो.
अच्छा,
तब हमें हर मिनट में 15, 13 और 14 CFM को एग्जॉस्ट कर रहा है. 14 CFM को फ्रेश एयर लेना पड़ेगा. If you want 1 air change per hour, if you want 2 air changes per hour, 800 divided by 30, okay, it will become 28 or 30 CFM per minute.
वहीं पर 1000 रहता है तो भी 60 से डिवाइड करते हैं.
सर 1000 होता है तो एक एयर चेंज चाहिए तो 60 से डिवाइड करना है.
जी,
ठीक है. 2 एयर चेंजेस चाहिए तो 30 से डिवाइड करना है. 3 एयर चेंजेस चाहिए तो 20 से डिवाइड करना है. ओके. 4 एयर चेंजेस चाहिए तो 15 से डिवाइड करना है.
ओके सर. सर एक बार डिह्यूमिडिफिकेशन के बारे में सर एक बार और बता देते कैसे हो रहा है.
बताता हूँ. Okay, now consider this part as chiller. Okay, compressor compresses. Okay, compressor compress करने के बाद after compressing, what will be the temperature?
Temperature,
What will be the
high temperature.
temperature of the refrigerant? Very hot, right?
Yes, sir.
It will be very hot, very high temperature. So now what we'll do is, by using cooling tower, this is called as cooling tower. By using cooling tower, we supply cold water. What we are supplying? Cold water. Now this cold water will be in the shell. Okay. Now this very high temperature refrigerant will become high temperature. Okay, high temperature refrigerant. Now this water will become hot water. This hot water will pump back again. These are pumps. Will pump back again to the cooling tower. Okay, we are pumping back again to the cooling tower. In the cooling tower, what we'll do is, we'll spray this water here. We'll spray this water. While spraying this water, we use an axial fan on the top to remove heat from this water. Again, this water will get cooled down and will be pumped back to the condenser. Again, it will cool the refrigerant. Okay, again it will come back, and so this, while in this process, there may be some water will gets evaporated. As the water is getting evaporated, to maintain the water level, we use makeup water tank. Okay, now, so as these temperatures are working here, in this case, the temperatures are with ambient temperatures. No insulation is required for the piping. Okay, no insulation is required for the piping, and this piping is called as condenser piping. This piping is called as condenser piping. Now, the hot refrigerant, okay, the hot refrigerant will move into the expansion valve. In the expansion valve, the refrigerant expands and will become very cold temperature, very low temperature, we say, cold temperature, chilled refrigerant, we say. So this chilled refrigerant will enter into the evaporator. This chilled refrigerant will enter into the evaporator. Already this pipe, this is called chilled water piping. Already chilled water piping is charged. Okay, is charged with water, filled with water. Already in this pipe there is a water. Whenever we switch on the pump, this cold water will enter into the evaporator. Heat exchange takes place. Cold water will become chilled water. Chilled water of 5 or 10 degrees centigrade. Very low temperature will become low temperature. Here, the water, the heat in the water is being absorbed by the refrigerant. Okay. Now this water is pumped to the cooling coil. This water is pumped to the cooling coil. In the cooling coil, cooling and dehumidification. So dehumidification kaisa ho raha hai? So what is the dew point temperature? The temperature at which water vapor molecules condenses into water molecules. सपोज आप एक कूल ड्रिंक ले लो, कूल ड्रिंक का टेम्परेचर 5 डिग्री सोचो, उसका ऊपर एक कूल ड्रिंक बॉटल के ऊपर आप ड्रॉपलेट्स देख सकता है ना, वाटर ड्रॉपलेट्स. ओके, सेम ऐसा इधर भी द टेम्परेचर इज ए ड्यू पॉइंट टेम्परेचर. whenever the air comes in contact with this coil, first cool hota hai. While cooling, the water vapor which is present in the water will get converted into water droplets. That means the water vapor level is decreasing in the air, which is called as a dehumidification. And the whatever water which is collected here is drained out by using a drain pan or drain line. Okay. So now here the return temperature may be around 20 degrees centigrade. Both temperatures are less than ambient temperatures. Both temperatures are less than ambient temperatures. So we go with insulation. The best insulation for chilled water piping is puff. The best insulation for chilled water piping is puff. Polyurethane foam. Puff means polyurethane foam. Puff insulation will do. Okay. Is it clear till now?
थोड़ा थोड़ा कंफ्यूजन है सर, एक बार रिपीट करिएगा तो क्लियर हो जाएगा.
कहाँ?
डीह्यूमिडिफिकेशन में और इधर से जो कूलिंग टावर से पानी वाटर जा रही है यहाँ पे,
उसका एक वीडियो दिखाता हूँ तब समझ पे आ जाएगा. ठीक है
जी सर.
फिर एक्सप्लेन करता हूँ. ये समर का. विंटर पे कैन वी रन द सेम सिस्टम? So before coming to winter, wait.
No, sir.
Website is invisible. With hosting a domains, you are in business.
Just watch this video.
Chiller system. Centralized air conditioning system used for large cooling capacity. Usually for commercial purposes. Chiller system consists of three main cycles, which are refrigerant cycle, chilled water cycle, and condenser water cycle. The components that are involved in refrigerant cycle are compressor, condenser, filter dryer, expansion valve and evaporator. For chilled water cycle, the component which involved are air handling unit and water pump. In condenser water cycle, the component that are needed for the process are cooling tower and water pump. Refrigerant cycle. Refrigerant cycle consists of four basic components, which are compressor, condenser, expansion device and evaporator. An additional component called filter dryer also included in the system. Compressor. Compressor works to increase the pressure of the refrigerant. In addition, it also serves to increase the temperature of the refrigerant higher than the temperature of condenser water so that the heat transfer can occur in the condenser. The refrigerant enters the compressor with low pressure gas and out with a high pressure gas condition. Type of compressor used was scroll hermetic type. Scroll compressor works based on gas at low pressure and temperature enter the suction line and go into the compressor. The low pressure and temperature gas is pressurized by the scroll compressor to high pressure and temperature gas. The high pressure and temperature gas is then passed through the discharge line and then go into the condenser. Condenser. The refrigerant in high pressure gas will be enter the condenser at a temperature higher than the temperature of condenser water. In condenser, the heat will be eliminated to the condenser water from the cooling tower through the process of convection and conduction. After the heat is removed, the refrigerant in high pressure gas is condensed into a high pressure liquid when out of the condenser. Condenser most commonly used is shell and tube type. Water is flowing through the tube while refrigerant liquid flooded in the shell. Filter dryer. Before the refrigerant flow to the next main component, it will be passes through an additional component called dryer. Dryer acts as a dirt filter and absorb if there is moisture in the refrigerant. This ensures that refrigerant is clean and dry before entering the expansion valve. Expansion valve. Expansion valve serves to reduce the pressure and control the flow of refrigerant going into the evaporator. When the pressure of refrigerant has declined drastically, the temperature will drop dramatically, which is lower than chilled water temperature. In a centralized system, expansion device DXV thermal expansion valve type is used. It works according to the temperature of the refrigerant which comes out from the evaporator. Sensing bulb placed on outflow of the evaporator works to detects temperature of the refrigerant and sends a signal to TXV. Needle valve in the TXV will control the flow of refrigerant based on the transmitted signal. Evaporator. The refrigerant in low-pressure liquid form coming out from the expansion valve will flow into the evaporator at low temperature. In evaporator, the heat from the chilled water which comes out from the air handling unit will be absorbed by the refrigerant due to the temperature difference produced. When the liquid refrigerant with low temperature and pressure absorb heat from the chilled water, the refrigerant will evaporate to low-pressure gas. The evaporator most commonly is used shell and tube type, where the refrigerant flow in the tube and the water flooded the shell. The evaporator is insulated with an insulation to reduce heat transfer. The refrigerant in low-pressure gas will return to the compressor and continue to the next cycle. Chilled water cycle. Chilled water cycle consists of two basic components which are air handling unit and water pump. Air handling unit. Air handling unit is a place where cold air is produced before it can be distributed. It consists of several key components such as cooling coil, fan motor, belting, filters and the casing. Chilled water produced in the evaporator will be flow into the air handling unit through a pipeline which is marked with dark blue color. This chilled water is known as chilled water supply. In air handling units, chilled water will then pass through the cooling coil. In the cooling coil, the hot air will go through the cooling coil and switch to cold air due to the heat transferred to chilled water. Cooling coil are commonly used in this system are tube and fin. After absorbing heat from the hot air, the chilled water will be known as chilled water return. Normally chilled water return pipe will be colored with light blue. Chilled water return will return back to the chiller to transfer the heat absorbed to the refrigerant in the evaporator. Water pump. This cycle will continue as long as the pump is functioning well. The pump used in the system is centrifugal type. The centrifugal pump works based on centrifugal force produced by the rotating impeller in the pump casing. For airflow system, It is operated using an auxiliary fan which to create the air cycle from the room and mix it with fresh air from the outside to the air handling unit and return back to the room. Type of fan used was centrifugal fan and powered by a motor and connected through a belting. The air flowing through a channel is called ducting. There are two types of air duct which are supply air duct and return air duct. These air ducts are coated with insulating material consisting of fiberglass wrapping with aluminium foil. It reduces heat transfer from the environment to the air duct. Air return to the air handling unit will pass through the filter before passing through a cooling coil and return back to the room. This to ensure that the air return into the room in a clean condition. Condenser water cycle. Condenser water cycle consists of two basic components which are cooling tower and water pump. Cooling tower. Cooling tower serves to cool down the temperature of condenser water that will be used to absorb heat in the refrigerant at the condenser. It consists of several components which are motor, sprinkler blade, water fin, water reservoir, buoys, and make-up water tank. From the condenser in chiller, condenser water flow to the cooling tower with the help of a centrifugal pumps. This chilled water is called condenser water return. This condenser water will pass through the rotating sprinkler blades on cooling towers. This rotating rotor blades using pressure generated by the condenser water itself. Water will gush down through the fins to reduce the speed of water going down. This can delay the time and the heat can be absorbed more effectively by the surrounding air that passing through the fins. Air through the fins is forced by a rotating fan on the sprinkler blade rotated by the motor. This fan rotates with its gusts upward. This will cause the air to move from the bottom to the top of the cooling tower where it is opposite to the flow of the condenser water. Condenser water which have eliminated their heat by the surrounding air will accumulate in the basin under the cooling tower. Condenser water that flowing out from cooling tower to the chiller is called condenser water supply. This condenser water will flow back to the chiller to continue heat absorbing work from the refrigerant. The buoy system at the water basin is connected to the make-up water tank. It works for adding water when the water level in the basin decreases at certain level due to evaporation. This condenser water cycle will continuously flow as long as the centrifugal pump is in good working condition. This explanation hopefully will enhance the student comprehension regarding the system. The centralized air conditioning.
Am I audible?
Yes, sir.
Hope you got the point right.
Right.
Winters पे हमें क्या करता है? We'll shut down this system. Completely this system will shut down. We'll use
Hot water generator.
hot water generator. And hot water generator heats the air. Here this cooling coil will become heating coil. Some systems heating coil will be different, cooling coil will be different. some systems, heating coil and cooling coil, both will be the same according to the climate views. Plus, this duct is connected with humidifier. The humidifier is nothing but hot air comes here. Here we will be adding the steam to the hot air. So as we are adding the steam to the hot air, it increases the moisture content in the air so that heating and humidification can be achieved. Okay. Make a note of this most important question, sir. Interview point of view, one of the most important question. When I have given my interview in LNT, they have asked this question: explain all air system. Okay. Make a note. Yes, Irshad Alam. Yes, tell me, any doubt?
Sir, I have a doubt.
Yes, tell me.
Sir, we are calling it all air system, but in the whole system we are using water. So why we are not calling it all air system?
We'll tell. Next, when I teach you the air water all water system, then you can find the difference. Completed?
No, sir.
Okay. Is it completed?
Yes, sir. Completed.
Okay. Okay, thank you. We'll meet tomorrow with all water system and air water system and package unit.
Okay, sir. Thank you, sir. Good night,
Okay.
sir.
Good night.